I'm also recording this. I've recorded all of my reviews for all of my sections. So there's plenty of review material out there. You also have all my YouTube videos. So Module 1 is domain, range, and end behavior. Domain is all values of x, range is all values of y, end behavior is this format here. As x goes to negative infinity and as x goes to positive infinity, what happens? Okay. Then module 2.1 is graphing absolute value functions. Module 2.2 is solving absolute value equations. And 2.3 is solving absolute value inequalities. Here's what I will tell you about this test. Overview, okay? I'm very well aware that we just went through a hurricane. I'm not going to try and throw you off, but I will be testing you on this, okay? If you know how to graph an absolute value function, you're good. If you know how to solve an absolute value equation, you're good. If you know how to solve an absolute value inequality, you're good. Okay? I'm not trying to throw you off. I'm not trying to pull a bunch of like seashells on you this time. I will be testing you on the very specific material. Okay? You've done homework on it. It's been presented to you. I'm going to do a review now. So you're going to be expected to solve simple questions and also more challenging questions of all of these types of things. All right? But I mean more challenging. You know, you'll see examples, okay, today of more challenging types of questions, all right? But the point is that if you don't know how to do any of these and you don't feel comfortable doing them, you can be assured that on the test you're still going to not feel comfortable. So you have to study to the point that you feel comfortable. Does that make sense? Okay. So if you feel comfortable doing this and you're just like, I got this, you're going to come into the test and you're going to be like, I got this, and you'll be able to do well. Okay. So let's get right into it. All right, so 2.1 is graphing absolute value functions. Let's see if I still have it. Yes. Okay. So with graphing absolute value functions, remember what it all comes down to is f of x equals a times the absolute value of x minus h plus k. Remember? That's the deal. Okay? That's the standard form of an absolute value function. Once you have that, you just have to answer the two simple questions. The first is, where's the vertex? Well, the vertex is at hk. And what's the slope? Very good. The slope is at A. The slope is A, specifically. Okay, remember we went through a long process just to get to this place, but now that we're here, we don't have to go through that process again. We just have to know how to apply it. So with that being said, I'll give you an example question. And this is almost exactly like what you could expect on the test. Okay? You get something like this and it'll say graph it. Okay? And if you can graph it, you will get all the points. Now, what are things that you could lose points on? Well, you don't have straight lines. You don't have all the points. You maybe do 1 point and then just kind of draw some squiggly lines off of that. You know, you do it just like I'm showing you how to do it, you will be assured to get all the points. Okay, so the first question is, where's the vertex? Someone raise your hand who could tell me. Where is the vertex? Yes, sir.
3, 1.
3, 1. Very good. Why isn't it negative 3? Okay, you can think of it that way. You flip the sign in this inside of it, right? So if it's negative inside, you make it positive. On the outside, you just keep it. So the vertex is at 3, 1. Good. So you can go ahead and plot that immediately. There's 3, 1. That's my vertex. And what's the slope, class? 2. Okay, so I know the slope is 2. So it means I go over 1, up 2. Over 1, up 2. Over 1, up 2. You see this? I'm taking the time to do multiple points, and I'm doing that for a reason. Okay? Because I want to be sure that when I draw my lines, they're accurate. You don't always have to have as many points as this, but you generally want to get as many points as you can. Just so you know you're drawing your lines in an accurate way. And there you go. Class, if you want to bring a straight edge and use that on the test, that's perfectly fine with me. Go ahead and bring it. So obviously, I'm not going to be grading you on the exact perfect straightness of your lines, but if you feel more comfortable, go for it. Any questions on how I did this? No? Okay. So let's go ahead and do another one. Remember, the form is f of x equals a times the absolute value of x minus h plus k. I will not be giving you this. I'm not going to tell you that's the form. You're going to have to remember that, okay? If I were you guys, I would look over it, like when you're sitting down and just like unpacking your stuff and doing that quick little flip through that a lot of students do, just look at it again. When you get your test, just write it on the top of the test. I used to do that all the time in college. No one's got any issues with that. You know, it's not cheating. Hey, welcome. Certainly. Go right ahead. You're welcome. So it's not cheating to remember something and then write it on the top of your test. So I recommend that you do it because then you don't have to worry about it later. All right, so go ahead and do this one on your own. F of x equals negative 3 x plus 1 plus 4. Okay? Go ahead and do that one on your own, please. And notice that is negative 3 at the front. God bless you. And class, you can rest. I didn't require that you get this, but you can definitely be assured that we will be doing lots of graphing in this class. So if you want to go ahead and get yourself a little composition notebook with graph paper in it, it might be wise to do so you're not doing the plots every single time. Maybe because sometimes we will take notes like this. Okay, so let's go ahead and solve this. Where's the vertex, class? Negative 1, 4, right? Negative 1, 4. Okay, so it's negative 1, 4 is the vertex. And what's the slope? Negative 3. Good job, class. Okay, so we go over and down 3. Over and down 3. Over and down 3. And the same way on the other side. Over 1, down 3. Over 1, down 3. Over 1, down 3. And then we go ahead and plot our lines. And that's it. It's negative, so you know it's facing down, right? It's going to be pointing downwards. Yeah? Okay, so let's talk about the domain, range, and end behavior. First off, domain. What is the domain of this function? What is the domain of this function? Yes, ma'am. Very good. Negative infinity to positive infinity. Okay, there's nowhere that I can put my pen to the left or the right where I won't eventually intersect the graph. Okay, so the domain is negative infinity to positive infinity. Class, if I just ask for the domain or the range of the end behavior, if I just ask for the domain and range, you can give it to me in whatever notation you want unless I specifically tell you. I generally default to interval notation because it's just the clearest to me. Okay, so the domain is negative infinity to positive infinity. What about the range? What about the range? Let's see. Does it have a beginning point? No, it goes all the way down, right? So that's negative infinity. We're going up to 4. Does it include 4? Raise your hand if you think it includes 4. Raise your hand. Yeah. It does. Right? That's a point. It's not an open point. The only way is if it didn't include 4 is if that was like an open point right there. Okay? So it includes 4. And then the end behavior. Remember, this format is what you know from the very beginning. X goes to negative infinity. F of x goes to something we don't know yet. X goes to positive infinity. Where does the function go? That's the question we're seeking to answer. So as x goes to negative infinity, I'm going to the left. My function is doing what? It's going down. It's decreasing without bounds. So f of x is going to what? Negative infinity. And as I go to the right towards positive infinity, my function is going down. It's decreasing without bound. So the function is going to where? Negative infinity. Okay? So there you go. That's basically what I'm going to be asking you guys for Module 1. Okay? Is domain, range, and end behavior. Because it's important that you guys understand that. Okay? Any questions on that? No? Okay. All right. We good? Okay. All right. So a couple more examples. Here, I'll leave that up for another 15 seconds. So these were relatively simple examples of graphing an absolute value function. You should be able to do this pretty simply. It's already in standard form. What's the vertex? What's the slope? Graph it. Okay? I will be looking for, like, you specifically showing me one way or another that you know the vertex or the slope. Okay? You need to make sure you have that vertex as a point. And if I were you, I would do just like this. Look, if I'm a student and I know my teacher does it a certain way and I want to get full points, I'm going to do it the same way my teacher does it. Bam. Vertex. A is what? -3. That way, if you make a mistake while graphing, at least I know that you knew what you were doing. You just made a mistake while graphing. Does that make sense? Okay? And then, at the same time, you got to make sure you do the right slope and you have the right vertex. Okay? Okay, any questions about that? Another thing that I wanted to say too is, like, don't do one point and then just draw the lines. I need to see at least another point. Does that make sense to you guys? Okay, at least 3 points on there. If you only have 1 point and it's just the vertex and you draw lines, I can't tell that you know the right slope. Okay? All right, so let's continue. A little bit more of a challenging one would be something like this. F of x equals the absolute value of 1/3 x, well, let's make it -1/3 actually. -1/3 x minus 2 plus 1. So it's -1/3 times x minus 2 plus 1. And so the first thing that should confront your mind here is that this is not in standard form. Since it's not in standard form, I can't just go ahead and start graphing. Because I have to get it in standard form before I graph. Otherwise, I'm playing with fire. Okay, so I have to get it into standard form. So what do I do? Who can raise their hand and tell me? Mr. Roy.
You take the fraction 1/3 out, and because it's inside the absolute value, it becomes positive.
Very good. You nailed it. Nicely done, sir. So you have to take the fraction out, but because it's inside of an absolute value, you don't take out the negative. It just becomes positive. So that becomes 1/3 x minus 2 plus 1. Now, before I continue with that, who can tell me if the fraction was positive and I took it out, would it become negative? No, it just stays positive. Okay? So you take a fraction out, no matter what it is, it's positive once you take it out. Okay, so now it's in standard form and I can continue. Does that make sense? Okay, so then the vertex is at 2, 1. And the slope is 1/3. And I'm golden. Okay? If you do something just like this and that's your work that you show me, I'll be so happy. That's like more than 50% right there. You understand? Okay? And so then you go ahead and graph. You graph 2, 1, 2, 1, over 2, up 1. Okay, make sure you take the time and you don't do 1, 2 by accident. Take the time, check your work. 2, 1, and then it's rise over run, so it's up 1/3. Right? It's rise over run, so it rises 1, goes over 3. Rises 1, goes over 3. Simple as that, yes sir.
Do you always go up 1, regardless?
No, usually I would go over 1. Okay, I'll address that in a second as soon as I finish graphing this. Okay, so the question was, do I always go up 1? Usually you guys have heard me say, oh, go over 1, up 3, or something like that. This time I said go up 1, over 3. So that was kind of confusing. But, okay, usually if my slope was 3, then this is the same as 3 over 1. And since it's rise over run, I will always go over 1 and then up 3. Does that make sense? If it's just a whole number, I just go over 1 and up 3. But this is rise over run, so I go over 3 and up 1. You see? Just got to remember rise over run. Okay? Over 3, up 1. Over 1, up 3. You guys see the difference? Okay. Any questions on that? Okay, good. All right. So, with that, we can go ahead and move on. Do you guys want me to give you another example that you can do by yourselves before we go on? Or you feel pretty good? Okay. No one's shooting their hands up at me, so. Okay. So, next, 2.2 rather. Solving absolute value equations. Okay? Remember, when we're doing this, we follow the IRS pattern. Isolate, rewrite, solve. Okay? You remember that, you're pretty much golden. Isolate the absolute value, rewrite as two equations, and then solve for x. Isolate, rewrite, solve. And an example of this would be something like this. 2 times the absolute value of x minus 1 plus 1 equals 5. Okay? 2 times the absolute value of x minus 1 plus 1 equals 5. So the first step here is we isolate. Who can tell me what the first step is to isolate it? Mr. Bates. Subtract 1 from both sides. Good. So 2 times the absolute value of x minus 1 equals 4. Mr. Bolton, can you tell me the next step? Divide both sides by 2. Good. Cross this out. I end up with the absolute value of x minus 1 equals 4 divided by 2 is 2. Have I successfully isolated the absolute value, class? Yes. It is by itself. Okay, and a lot of people get confused here. Well, there's the x minus 1 in there. No. I'm not saying isolate the x. I'm saying isolate the absolute value. If you kind of cover up this, you see the absolute value is by itself, right? Okay. So I've isolated the absolute value, so that's done. So now I go on to the rewrite step. In order to rewrite, first I drop the absolute value, so it's x minus 1 equals 2. And then I rewrite as a second equation, x minus 1 equals what, class? Negative 2. Very good. And once I've done that, I've completed the rewrite step. So that was fast. Okay. Now I go ahead and I solve. Simple. I'm solving for x. I add 1 to both sides of both equations. And I end up with x equals 3. X equals, negative 2 plus 1 is 3. Negative 2 plus 1 is negative 1. And these are my answers. X equals 3 and x equals negative 1. And I have completed my solve step and I'm done. That makes sense? Okay. All right, class, just kind of a word to the wise here. If you just write down 3 or negative 1, yeah, those are the right answers, but I need to see x equals 3, x equals negative 1. Okay? Yes, sir. Yeah, sure. Any questions on how I did this? No. It's pretty solid? Good. All right, so I'm going to let you go ahead and do one on your own. And remember, class, I am videotaping this whole thing, and it will be on YouTube. Okay, so I'm going to let you do one on your own now. Let's do negative 3 times the absolute value of x plus, well, let's make it hard, 2x plus 1 minus 2 equals negative 8. So the first one was kind of an easier one. This one would be a more challenging one. Both of which you are expected to be able to solve fully. Okay. Give you another 20 seconds. Remember, we're always finding isolate, rewrite, solve. Isolate, rewrite, solve. That's always our process. All right, first step, add 2 to both sides. Negative 3 times the absolute value of 2x plus 1 equals -6. Next step, divide both sides by -3. Absolute value of 2x plus 1 equals 2. I've completed my isolation process. Now I rewrite. Drop the absolute value, 2x plus 1 equals 2. And 2x plus 1 equals -2. Okay, I've now completed my rewrite process, and now I solve for x. Subtract 1 from both sides of both equations. Two x equals 1, 2x equals -3. Divide both sides by 2. And I get x equals 1/2 and x equals -3/2. Yes, sir.
If we get a fraction like that, do we make it a mixed number, or is that more?
-3/2. You can put it in whatever form you want. I would recommend that either you just leave it as an improper fraction or just put it as a decimal, unless you feel really comfortable changing that back into a mixed number.
What do you prefer?
I prefer you keep it as an improper fraction. I don't know. What do you say, Mrs. Hendry?
Improper fraction only.
There you go. That's the final word. So I'd say keep it as an improper fraction. Sometimes on the SAT or something like that, you might be given an answer that would be a mixed number, and you'd have to be able to change it. But there's no reason to do it. That's fine with me, unless it's a multiple choice question. Okay. All right. Any questions on how I did that? You see how this was a little bit more of a challenging question? Okay. You know, there's more steps to it, but it's the same process. Isolate, rewrite, and finally solve. Got it? Okay. Any questions? Okay. All right. So let's move forward. That was 2.2. Let's go ahead now to 2.3, which is solving absolute value inequalities. Okay, solving absolute value inequalities. All right. Once again, we're doing the same exact process. Isolate, rewrite, solve. The only thing that's different here is the rewrite process is a little bit different. It's the only difference. Isolate, rewrite, solve. Okay, so what's an example of this? Well, I'll start with a simple example so you can get used to the form. Absolute value of x is less than 5. Okay? It's already isolated, right? So that part is done. So I just rewrite it. It's less than, so it's and, right? Less than 5, and you take this inequality here, you move it over, and you take this number 5, you move it over, and make it negative, and you're done. Okay? So that was the rewrite process, and since x was just by itself, you already solved it as well. You see? That's the simplest possible thing that I could give you. Okay? I just wanted to show you this so you could see this rewrite process for less than is how you do it. You take this over, and then you take the number over and make it negative. Okay? That's if it's less than. What about if it's more than? Absolute value of x is more than, greater than 5. Okay? It's already isolated. So now you rewrite. It's more than, excuse me, you always drop the absolute value. That's your first step. But it's more than, so it's not and, it's what class? It's more than or. So it's or, x is more than 5, or x is. Take the sign, flip it, take the number, flip it as well, make it negative. You see? So that's if it's more than or greater than. Or, first you always drop the absolute value. This case it's or, flip the inequality, and then make the number negative. You see? Does that make sense? Okay. So those are the kind of simplest examples that I could potentially give you. I probably won't give you something that simple. But with that being said, you may be asked to graph it. And in that case, if this was a number line, for instance, if this was -5 and this was 5, this is x is in between -5 and 5, exclusive, and that would be how I would graph it on a number line. Is that clear? Okay. In this case, it's also -5 and 5, but x is greater than 5, so it would be these solutions here, and x is less than -5, so it would be these solutions here. Does that make sense to you guys? Yeah? Okay. Any questions on that? Okay. Now, just because I realize I didn't cover it and I should have, what if I had like x is just like an inequality, and kind of just watch this. Don't maybe take notes unless you want to go back to your section 2.2 notes. What if I got x equals negative? What was the answer for the last one for the equality? X equals, what was it? Not the 1/2 one, the easier one before that. What was it? 3 and -1. So if I have x equals 3 and x equals -1, and I'm asked to plot that on a number line, it's just, okay, here's -1, put the point there, and here's 3, you just put the points. Okay, that's graphing that on a number line. You're just plotting the points. Does that make sense, you guys? Okay. With the inequality, I have to actually show the domain of solutions, right? So it's not just one point. It's this whole domain of solutions. But with just an equation, you're only going to have 1 or 2 solutions, right? Okay. Any questions on that? No? Okay. So now a more challenging one would be potentially something like this. 2 times the absolute value of x minus 1 plus 1 is less than or equal to 5. Now remember, we have to do the isolate, rewrite, solve process. IRS. Okay. What's the first step here, class? Subtract 1 from both sides. 2 times the absolute value of x minus 1 is less than or equal to 4. Now, divide both sides by 2. Absolute value of x minus 1 is less than or equal to 2. You guys following this? Okay. I've finished my isolation process. Now I rewrite it. I always rewrite in the same way. The first step, x minus 1 is less than or equal to 2. I drop it. It's less than, so it's and, so I bring this over. Bring the number over and make it negative. Yeah? I've now finished my rewrite, and now I solve. And to solve, I just add 1 to all 3 sides there. So I get -1 is less than or equal to x is less than or equal to 3 is my solution. I'm done. And then if I'm asked to plot this on a number line, it would just be something like this. Here's -1, here's 3. It's in between the two. It's inclusive. How do I know it's inclusive, class? Because it's a closed point, but it's inclusive because it's not just less than, it's less than and equal to. You see? And those are my solutions. Okay, is that pretty clear, class? Yeah? Okay. Now, I'm probably going to do one more, but before I do that, I'm just going to cover, oh, sorry. Well, I probably should do that. Okay, I'm going to need to move forward. So, what if I have 2 or 3 times the absolute value of x plus 2 minus 1 is greater than 5? Okay, I'm going to have to go relatively quickly, class, so if you want to just sit back, you remember you can always watch this in a video. I'm going to add 1 to both sides. Let's not pack up yet, please. 3 times the absolute value of x plus 2 is greater than 6. What do I do now, class? Divide by 3. Absolute value of x plus 2 is greater than 2. Have I finished isolating? Yes. My absolute value is by itself. So I rewrite it. X plus 2 is more than 2 or greater than 2. It's more than, so it's or. X plus 2 is less than negative 2. You see? And then to solve, I subtract 2 from both inequalities on both sides. And I end up with x is greater than 0 or x is less than negative 4. If I plot this, here's negative 4, here's 0, x is greater than 0, it's exclusive, and x is less than negative 4, exclusive. You see? Does that make sense? We clear on this? Now don't pack up yet. I've got 2 more things I need to remind you of. Okay? So listen. Okay. Remember, it's on video if you didn't take that in notes. Okay? What about if I have absolute value of x is less than a negative number? Can absolute value ever be negative? No. So what is this? No solutions. Okay. What about absolute value of x is greater than a negative number? All real numbers. And that's how you write that. That R with that double line there. Or all real numbers. Okay, because there's nothing I can plug in there that would ever be less than negative 2. So everything is going to be greater than negative 2, no matter what I plug in. Okay, and the only other thing that I forgot to mention here, what if I have absolute value of x or absolute value of x minus 2 or whatever it is equals negative 3? Are there any solutions to that? No. It doesn't matter what's inside the absolute value. If I isolate the absolute value and it's equal to a negative number, that's no solutions. Got it? Is that clear to everybody? All right. That's it. Good job, class. Thank you for your attention today. Remember, your test is tomorrow, and it is right after lunch. Okay, so make sure you study. Make sure you are prepared for the test. I have health class after school today. You okay? Guys, stay in your seats, please. Stay in your seats. You all right? Go ahead.
Question: did you sign 2.3 on Wednesday or Tuesday? Because I wasn't here Wednesday.